Hi, my name is Yuva, and I'm here today to talk with you about Testng. Before we start to use CLAN for test automation, let us understand Testng, a test framework. In the next few minutes, you will see how Testng can be used to write test case. So let's get started. CLAN is a Java-based Testng-driven framework. Testng provides a user with capabilities through which any developer can dictate the way the test case should execute. It also provides a way to group and run test cases in parallel. So what does it offer? It offers annotations, groups and dependencies, data-driven testing, listeners, and parallelism. Annotations. It is used by Testng as a way to recognize test methods and its related groups and configurations. Groups and dependencies. A test case need not be an independent entity. Test cases can be grouped and also be tagged with dependencies. Data-driven testing. A facility to supply data to a test method in a sequential or a parallel way. Parallelism. An option by which a user can decide running test cases parallelly. Listeners. Testng provides a way to tap into its events by providing listeners. For example, a user can add a listener to add a node to the console which prints the test detail as and when the test is run. And along with these, Testng also provides suites that contain a description of test cases to run. It is parsed by Testng to load the respective test cases. In fact, CLine uses Testng listeners internally for some of the core activities. I will be covering annotations, groups, and dependencies in this video. The rest will follow in part 2. You will see a practical walkthrough of all these features. Before starting to learn what you can do with CLine, let us first create a sample project. Please make sure you have installed JDK 1.7, Maven 3, and any IDE of your choice before proceeding further. The idea here is to run this Maven command, which will in turn create a sample project, and this can be imported as a Maven project inside a IDE. This command can be found under http://cline.io under Getting Started with CLine Archetype section. A test case. A test case is a Java class which is annotated with Testng annotations. Sometimes a class itself can be annotated with @test, which signifies that all the methods inside a class will be a test method. A test case uses assertions to validate a condition and mark a test case as pass or fail. Assertions in CLine are called CLine asserts. So what does assertions do? It validates a condition to mark a test case as pass or fail. An assert can be a hard assert or a soft assert. Hard assert will abort the test case execution if a condition fails, whereas a soft assert will continue to run and, and at the end of the test case, it will mark it as failure if the condition fails. Here is a sample test case. It is just a simple Java class, whereas the methods inside the class are annotated with @test. It's a way to tell Testng that this is a test method and should be executed. If you take a closer look at this example, I've mentioned the usage of hard assert as well as a soft assert. A soft assert signature will start with cline asserts.verify followed by a true or a false or a equals, whereas a hard assert signature will be like cline asserts.assert true or a false or a equals. Now that you have seen what is a test case, let's get started with the annotations provided by Testng. So these are some of the list of annotations uh, available in Testng. There are other few which will be covered in the later chapters. So the first annotation is at before method and at after method. The annotated test method will be run before or after each test method, at before groups and at after groups. The list of groups that this configuration method will run before or after. The next one is at before class and at after class. The annotated method will run before the first test method in the class or after the last test method in the class. The next one is at before test and at after test. The annotated test method will run before or after any test method belonging to the classes inside the test stack is run. The last one is at before suit and at after suit. The annotated test method will be run before all tests in the suite have run. Similarly for the after suite. So let's get started with the practical walkthrough. Before I begin executing a test case, I would like to show the sample structure of the project. So this is how my project looks like. The source test Java folder will contain the packages, which will in turn contain the test scripts. The source test resources package folder will contain the suite files and other resource files required by the test scripts. In addition to this, right now I'm using the Eclipse IDE. So from Eclipse, whenever I execute a test case, it is invoked using the Eclipse Testng plugin. The other way for running a Testng case is to write a Maven command which will invoke the Surefire plugin and it will run the test cases. More of it later. So this is my sample test case called demo calculator test. Inside it, I have two test methods, test addition and test difference, which is performing very basic operations like add numbers and subtract and a sample assert. On top of this, I have added the annotations at before test, at before class, at before method, and also at after test, at after class, and at after method respectively. So let me run this and see what happens. So I'm running the test cases using the Testng plugin. So this is the output I get. I have introduced uh, printout statements for illustration purposes. So the before test and after test would have executed once. The before test and before class and after class would also have executed once. The difference between the two will be explained with another example. If you look at this closely, for each test method, the before method and after method will be invoked. In this case, the before method and after method was invoked for test addition test case and also separately for test different test case. I would like to introduce another example which contains the before suite in addition to the previous example. Now, when I was explaining about before test or after test, I said that the annotated test method will be run before or after any test method belonging to the classes inside the test tag is run. So the test tag which I mentioned previously will be present inside a suite file which will in turn contain the classes tag followed by the class names. So a test tag is identified by a name which will be printed in the console whenever the test case is executed. So in this case, I have a suite called cline sample test inside which I have a test called training test which contains a list of classes called demo calculator test and calculator 2 test. Now if I execute it, let's see what happens. So if you see here, the before suit will be the first one to get executed before any other test method or test class is initialized, followed by the before test. If you watch closely, now I have specified two classes inside the test tag. So the before test and the after test will execute once after and before all the test classes have completed its execution. The next thing to note here is The before class and the after class for demo calculator test will be executed, and whenever the calculator test2 is loaded and executed, the before class 2 and after class 2 will be executed. So this is how the annotation works. Once you get to understand the order of the annotations, it will be easier to outline your test case in such a way that you can choose the annotations of your choice. So let's get started with groups in Testng. So Testng provides a facility to group test methods using meaningful names. These names can depict a scenario or any other name of user choice. So the Testng methods or configurations can be designated to a group, which can be selectively run from a suite file using include or exclude options, which we'll be seeing in our demo. And a test case can belong to n number of groups. So let's take a look at an example for groups in Testng. So I have a class called calculator test, and the, the test methods like test addition, test negative addition, and test difference, out of which test addition and test negative addition belongs to groups add, whereas the test negative addition also belongs to an additional group called negative add. So this is how my suite file will look like. So whenever I specify a group, I should inform testng that this so and so group should be added and it should be executed. How do I do that? This is specifically done using the groups tag under the test tag, and the test methods that needs to be run should be specified under the run tag followed by include or exclude. In this case, I want the test methods belonging to the group add to be executed. So let me execute it. So as you can see, the test methods belonging to the group add will be executed. Please note that I have also mentioned a group for the before class. Otherwise, we would get an error. Also, if you note closely, whenever we specify the group add, both the methods will be executed. Now, what happens if I exclude the negative add? I've just excluded the negative add. Now I'll run the test case. So now the negative add has been excluded. So this shows that whenever we designate groups to test methods, Testng will first consider the group names under the include tag, and then it will apply the exclusion for the group names under the exclude tag, and finally the resultant set of groups will be executed by the Testng. In this case, although the test negative addition group test method belongs to the group add and negative add, since we have specified the exclusion for negative add group, it was excluded and only the test addition method was run. This is one of the basic things that needs to be understood with respect to groups. Followed by groups in Testng, let's look further into specifying dependencies in annotations. When automating any test scenarios, there comes a situation where the test methods will be dependent And sometimes a group of test methods must be executed before another test methods. Testng solves this requirement using the depends on parameters inside a test stack and also the configuration methods. The parameters are depends on methods and depends on groups. Whenever a test method depends on another one, it can be specified using the depends on methods. Whenever a test method depends on a group, it can be specified using the depends on groups. A dependency specified in an annotation can be a hard dependency or a soft dependency. So let's look at an example of specifying dependency in annotation. This is the same class which was used in groups in Testng section, and the test methods of interest are test difference and test negative difference. If you take a closer look, the test negative difference depends on methods test difference. I can even specify more than one method in this depends on methods. In this case, let's see what happens when I execute the calculated test class. So the test difference is successful and then the test negative difference is executed. Things are fine now. Now let me fail the test case to understand what is hard dependency. Now what happens is there are 4 tests which are run. There was a single failure, and this is something new. One of the test methods was skipped, and the name of the test method is test negative difference. So what happened here is when test difference failed, the methods that are dependent on the test difference are skipped. This is called as hard dependency. Now this might be feasible for certain scenarios, but what if I need to execute the test negative difference irrespective of the result from test difference? That is whether the test difference is pass or fail. I can enforce this using the parameter always run equal to true, meaning whenever this test negative difference is dependent on test difference, it does not need to worry about the result of its dependent methods, and it can execute after its dependent methods have been run. To put it in simple words, I want the test negative difference to run after test difference, but this should not be skipped. So this is done using the always run to true. So if I execute this again, now the skips count will be 0 and the failure will be 1. Test negative difference would have been executed. This is one classic example of differentiating between hard dependency and soft dependency. The same thing is applicable to groups.